Hi, line. Hello? Hello? Where is that voice coming from? Hi, line. It's me, a box. A box? What is a box? How do you make one? Why don't you turn so you can become like me? What do you mean, like you? What are you again? I'm box. See, I can go right and left and front and back. So with 4 of you going not only right and left like me, 2 lines like you, but I can connect them at the ends with the 2 lines like you, front and back. What? Yeah, just connect the lines, but make sure they're at 90 degrees to each other. I don't see what this front and back business is. I don't get it. 90 degrees from where? Well, the right to left is called the x-axis, which is what you are. But now, the front and back is called the y-axis. This way, the kids at Seacrest learning geometry, in Euclidean space to be exact, can not only draw 2-dimensional objects like me, but can also graph things on paper. I get that right and left, I know I am the x-axis, but forgive me, I just don't see how these other lines are going to where, and what is 90 degrees anyway? Wow, line segment, you're so obtuse. Hi, box. Hello? Hello? Where's that voice coming from? Hi, box. It's me, a cube. A cube? What's a cube? How do you make one? Well, you can be like me by adding 4 more lines up from the paper that you're on, then attach a box like yourself at the ends of those lines so you can be like me. What do you mean, like you? What are you again? I am a cube, see? I can not only go right and left and front and back, but I also have up and down. It's called depth, or height. See, you're made up of 4 lines at right angles to each other at the corners. We'll just keep going. What? Keep going where? At the corners where your lines meet, add a line at 90 degrees from the 2 lines, kind of away from the other 2 lines. So each corner now has 3 lines, each line 90 degrees from each other. That will give you depth. Then attach yourself again, a copy of yourself, at the ends of the lines, and then you'll have me. I don't see what this up and down, this depth business, I don't get it. 90 degrees to where? Well, the right to left is called the x-axis. The front to back is called the y-axis. You already know this. Now, depth, with these 2 new lines reaching into space, that's called the z-axis. This way, the kids at Seacrest learning geometry, in Euclidean space to be exact, can not only draw 3-dimensional objects like me, but can also graph things in space. I get the right to left and front to back. I know I am on both the x-axis and the y-axis, but forgive me, I just don't see how these other lines are going to where. And what is 90 degrees away from me and you mean anyway? I mean, you're so obtuse. That poor box. And worse, that poor pathetic line segment. They have no idea how neat it is to be 3-dimensional. I have height, I have length, and I have depth. I have all that there is. I have volume, I occupy all manner of space. I am the greatest. Hi, Cube. Hello? Hello? Where's that voice coming from? Hi, Cube, it's me, Time. Time? What is time? How do you make one? Well, you can't make time, but I am a higher dimension than you. impossible! I'm the greatest dimension. I'm the third dimension. Well, actually, no. There are infinite dimensions. In fact, if we were to extend lines from each of your corners, those are called vertices, plural vertex, by the way, 90 degrees from each other line, we can make you a hypercube. A hypercube is a fourth dimensional. You can't do that! You would walk into walls! Look at the corner of a room, 90 degrees away from the three lines that would go into the wall. Exactly. That's how ghosts work, don't you know? Are you kidding me? That's impossible. I can see why you don't get it. For after all, we are talking about non-Euclidean space. But let's get back to me. Okay, so what are you? I am an ocean. In fact, something that people use to measure rates. No one can touch me or see me, but they know what I am. There, that is why I'm always sometimes referred to as the fourth dimension. But more importantly, without me, no one would ever find you. What do you mean you would never find me? I'm right here. Right, you are here, right now. So now is time. Here. But I always exist. But not everywhere, right? Right, but... So, without me, I can pinpoint you in space. This is what Einstein called space-time. But let me give you an example. If I tell one of those bright math kids at Seacrest your closest vertex is at a particular x, y, and z coordinate in space, I don't tell them and you'll be there. So how can they be certain to find you? But I always exist. Yes, but not everywhere. So to know where you will like to be, the kids at Seacrest need me. There's no way whatsoever that you can be found without space-time. 3 dimensions in space, but alas, 4th dimensions include time. Einstein proved it. I'm so lost. Exactly. Without me, you are lost. I'm so confused.
High time.
What?
There is a 5th dimension, beyond that which is known to... It is a dimension as vast as space and as timeless as infinity. It is the middle ground between light and shadow, between science and superstition, and it lies between the pit of man's fears and the summit of his knowledge. This is the dimension of imagination. It is an area which we call the Twilight Zone.